Linear magnification. Linear magnification is defined as the ratio of image distance by the object distance. It is also defined as the ratio of image height to the object height. It means if this is a concave mirror, and we have seen this earlier. So if this is the object height, an image will be produced somewhere in between the C and F. So this is H1, this is H2, and this distance is U, this distance is V. The ratio of image distance to the object distance is called the linear magnification, and another way around, that image height by the object height is called the linear magnification. What is this unit? Linear magnification has no unit, because you can see it's a ratio. Ratios never have units. The dimension of H2 is length, and the dimension of H1 is also length. So no unit. Okay, they are ratios. They just compare. When we say m is equals to 3, it means H2 by H1 is equals to 3. This means that the image height is 3 times of the H1. So it is always saying 3 times or something like that. Now what does this negative sign means? In case of mirrors, we see there is a negative sign minus V by U. What does minus sign means? Negative sign implies, negative sign means is the image real or virtual? What is it? If m equals to negative, so image will be real and inverted. And if m equals to positive, image equals to virtual and erect. That's it. This is linear magnification. Now this is one particular relation of linear magnification. M is equals to minus V by U and or H2 by H1. We will establish some new other relations. Let's see. So we know mirror equation states 1 by F equals to 1 by V plus 1 by U. So if we multiply both the left hand side and right hand side by V or U, let's say I multiply with U. So U by F is equals to U by V plus U by U, or U by F is equals to U by V plus 1. So now we can write U by F minus 1 U by V, or U minus F by F is equals to U by V. So taking reciprocal now, V by U is equals to F by U minus F, but magnification is minus V by U, so we will multiply it by minus. If we multiply left hand side and right hand side by minus, then the above expression becomes minus V by U equals to minus F by, so minus, sorry, so it's going to be U minus F, or we can write minus V by U is equal to F by F minus U, or M equals to F by F minus U. This is the relation for magnification. So if you know the focal length and if you know the object distance, or you know the magnification, you can all definitely find the image object distance. So what I mean to say is that if you know the focal length and you know the magnification, you can easily find out the object distance. Simple that. Now similarly I have similarly you can find out in terms of f and v also magnification. I leave this for you to derive on your own. That is this relation, m is equals to f minus v by f. I'll leave this for you to derive. You can multiply the Miller equation by v and you can easily establish it. Remember that you need to multiply that minus what I've done in this step, because linear magnification is minus v by u. Remember that. Okay. Now as we have done linear magnification, now let us solve some problems. Okay. 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 So we have here a numerical which says that a rod of length 5 centimeter lies along the principal axis of a concave mirror of focal length 15 centimeter in such a way that the end closer to the pole is 30 centimeter away from it on the length of the image. To understand this question, we will draw the diagram first. I'll first draw the principal axis. This is the concave mirror. This is C. It says that the concave mirror of focal length 15 centimeter. Okay, in such way that the end closer to the pole is 30 centimeter. End closer to the pole is 30 centimeter. That means if this is the rod, this is the rod, this distance is 5 cm, this is point A, this is point B. Okay, so this is 30 centimeter, this is the focal length f, which is 15 centimeter, right? So the focal length 50 centimeter and it is kept pole end closer to the pole is 30 cm. That means the out of the two edges of the rod, one edge is at the C, and we know any object which is placed at the C image will be formed at C only. So I know the image formed by the image of the A will be here. But what about B? Where will be B? Let us find out the image distance for the end B. So we just need to find the image distance for, and then we can plot it. Okay. So for the end B, u will be equals to 30 plus the length of the rod. That gives me 30 plus 5, that gives minus 35 centimeter. Okay, why minus? Because sign convention. And focal length is minus 15 centimeter. So we know the relation now. 1 by f is equals to 1 by u plus 1 by v. What do we need to find? We need to find v. So 1 by v must be equals to 1 by f minus 1 by u. So we can directly write this as v will be equals to f into u by u minus f. Now when doing maths, here is a trick. You need to always remember this formula. No need to come from the mirror equation, derive two more steps and then come to this solution. If you need to find v, it will be fu by u minus f. If you need to find u, it would be fv by v minus f. That's it. Remember this. So f is equals to now how much? Minus 15 into minus 35 divided by minus 35 minus minus 15. So minus, it becomes plus now. So 15 into 35 divided by 35 minus 35 plus 15, that gives me 20. So 15 into 35 and it gives me minus 20. So 5 3s are 15, 5 4s are 20. So this one, this is a 15, 35 into 3 will be 5 3s are 15 and 1, 9 and 10, 105. 105 by 4. This is minus 105 by 4, which if you divide 105 divided by 4, if I do 4 2s are 8, 4 6 are 24.02 and so on. So that means approximately it comes out to be 26 cm, right? So then what is the length of the image? Yeah, what is the length of the image? To find the length of the image, we know it should be 30 length of the image, rod of length 5 cm lies along the principal concave focal length in such a way the end closer to the is that okay. So in this case it should be 30 centimeter. No, it is coming 26 centimeter. Okay, that means this side is, so it should be 30 minus 26. That gives me approximately 4 centimeter, right? So the image will be somewhere here. Not, let me take the, it is like this. Here, this is where the image will be formed. So this is the B, this image will be formed at B prime. Correct? I hope you understand. You can go through and let me explain you once again what is happening. This is a rod of length 5 centimeter with this one end kept at the center of curvature and other end is 5 centimeter away from the center of curvature. Okay. So now what will happen? So we know for any so if you remember this diagram I taught you earlier from the mirror in one of my lectures, I have taught you the image formation. So if you see, if you remember, any object which is placed behind C, image will be between C and F, isn't it or not? The point B is behind C, so its image will be between C and F. That's why. So B prime is forming between C and F. It's a very conceptual problem. Keep this type of problem in mind. We will look into one more problem. Let's see now. Okay. Another type of question regarding magnification. Where should an object be placed in front of a concave mirror of focal length 15 centimeter to have a magnification 3 in case of real image and virtual image? You note nothing about the image distance, object distance is not been provided. So how can you solve this? So what is given to you? Given m equals to, we will take the first case for real image. So m equals to minus 3, which is equals to how much? Minus v by u. Keep that in mind. You have to take, as the image is real, is minus and the relation is also minus. So if I simplify this, I get v equals to 3u. This is what I needed to teach you. Then focal length is given. F is equals to 15 centimeter, that is minus 15 cm. That is a concave mirror. So then what do you need to find? We need to find the 1 by f is equals to, we need to find the object distance. 1 by f is equals to 1 by v plus 1 by u. So then 1 by 3u plus 1 by u, 1 by f. So 1 by f is equals to, now we simplify this, this would be 3u, this would be 3 plus 1, that gives me 4 by 3u, 4 by 3u. So f must be equals to 3u by 4, 3u by 4, or u must be equals to 4f by 3, but f is minus 15. So 4 into minus 15 by 3. So that means 60. 4 into 15 is 60. 60 divided by 3, it would be minus 20. So u is 20. So when you keep the object at minus 20 centimeter from the concave mirror, you will have an image whose magnification will be 3. Magnification will be 3. That means the image height would be 3 times of the object height. Okay. Now let us solve it for the second case. That is for the virtual. In case of virtual image, m must be equals to plus 3. That is equals to minus v by u. So in this case, v must be equals to minus 3u. So similarly, if I do again, I'm writing this relation directly. So 1 by f must be equals to minus 1 by 3u plus 1 by u. So that should give me again 3u LCM. So this time it would be 3 minus 1. That gives me 2. So 2 by 3u, 1 by f is equals to. So then f must be equals to 3u by 2, or u must be equals to 2f by 3, 2 into minus 15 by 3, that gives me 30. 30 by 3, that gives me minus 10. Minus 10 cm. That means u in this case is equals to minus 10 centimeter. That's it. This is how a problem like this will be solved. Now, what you should take away from this particular kind of numerical? Remember, you have to take this relation as minus, as the real image is minus, so you should be minus. Don't think as the image is coming real, I should not place a minus, then it becomes a virtual image. So this is the takeaway from here. Don't confuse with the why this is also minus, this is also minus. Don't confuse yourself here. Many students do so. Don't do that. Keep that in mind. And the things to highlight here is that in case of virtual, this will be plus, this is minus. Don't disturb the linear magnification relation. So the point to take away from here in this kind of problem, don't disturb the relation of m while using value of m. Remember that. Means if it should be always minus v by u. Don't try to negate it. Thank you. See you in next video.